Hi there, guys. Well, welcome back. We're working towards 3N here in the Oxford HLAA mathematics book. And in fact, there's only one question to deal with here. It's example 33, and it's about factorizing a cubic in order to find its roots. In fact, here we're not talking about complex numbers. We're just talking about if this cubic factorizes with real roots, so with factors with real numbers inside the brackets, then how do you factorize it in order to find your roots? Okay, so that's what we're up to. There's a little bit of discussion beforehand talking about the general formula for solving a cubic polynomial, cubic equation, if you like. And just as there's a formula for solving a quadratic, there's also a formula for solving a cubic. The problem is, though, I was just checking this one out beforehand. So the problem is here that the formula is totally messy. I mean, look at the quadratic formula. Remember how long that one took people to kind of remember. Let's just zoom in a little bit here. So that look at the quadratic one, see how long that took to get used to, get familiar with. Well, the cubic one looks like this. I mean, it's a total mess. Now, it can be simplified if you say, well, actually, I'm going to call Q, R, and P these things, which turn up quite often in this formula. So we can simplify this thing. You can see in the original formula, we've got the coefficients of x cubed, x squared, x, and x to the 0, a, b, c, and d. And well, we can simplify the formula if we note that p is equal to, q is equal to, r is equal to, that there are expressions which keep turning up within this single formula. However, we don't learn this. I like this website, Vanderbilt, who was just saying here as well that part of the reason why we wouldn't necessarily teach this, apart from it being a total mess and it would take you half of your exam to get through one of these questions, is that in the middle of doing these calculations, you might have to deal with complex numbers. And so, although we're aware of complex numbers and how to work with them, certainly you wouldn't introduce it before that. So you're going to have to work with complex numbers within this formula in order to get your answers out. Okay, anyway, we're not dealing with that. That's what it is. It's a bit of history here. It's saying there's a group of Italian mathematicians, Del Ferro, Tartaglia, and Cardano in the 13th and 14th century that developed this formula. Anyway, okay, well, let's flick on. Let's actually try and solve this cubic here. And I mean, this one's quite interesting in that they have an interesting approach, which I wouldn't necessarily take. And if you're familiar with factorizing by splitting the middle term, okay, and I'm not talking about those situations where you have, 2x squared plus something, and you're saying, okay, well, let's do a times by c, and then we need to find two numbers that times together to give you a times by c, and then two numbers which add together to b. I'm not talking about that necessarily. I'm just talking about the regular factorization which you do. Like, for example, if you do x squared, I don't know, let's take minus 12 there, and we could think that we have plus x in the middle, and we can factorize this. And a lot of people would just factorize this by saying, well, yeah, sure, this is plus 4 and minus 3. I can see that two numbers timesing together give minus 12, and adding together to give plus 1 is plus 4 and minus 3. Now, we've done this before, but if you're the type of person who splits that middle term into two factors and then factorize the left-hand side and the right-hand side, then the approach that the book has might be before you. Okay, but I'm going to go through another method, and I'm going to go through the book method as well. But just to say, I'll do the book method first, but if you don't like this method, you can skip ahead, but you might be interested anyway. So for this one, what people might do is say, well, okay, we've got to split this middle term so that it's a factor of both. One of them is a factor of shares a factor with x squared, and one of them shares a factor with minus 12. So that requires some thought here. So, for example, we might think, I don't know, maybe minus 1 shares a factor with this, so sharing x minus 1 there. But then if we split it up, we're going to realize that we're going to need 2x there. And sure, that shares a factor with the minus 12. But then when you factorize these two things here, you have to end up with the same factor. And we don't see that when we're factorizing those two things there. So again, you have to realize, you have to think through your options and think, okay, well, if I put, say, for example, a minus 3 there and a plus 4x there, so you need to go through combinations, which will then give you a factorization here, okay, which has the same factor as the factorization that you're going to get on the other side. And that's what we get there. And then now you can say we've got x plus 4 lots of x minus 3. Okay, now I'm suspecting that most of you don't do that, in which case you're not going to like what the book does. Okay, so the book is saying x cubed minus 7x plus 6. Well, we can see here that we could split this up into two factors, and I can already see that 6 is a factor of 6 here. Maybe I could make a 6 here as well. So maybe I could make a 6x plus 6, and if that was a minus 6x, maybe I could make an x there. Okay, not an x there, sorry, a minus x there. So now I've made a total of minus 7x. Now that's through a little bit of trial and error, because we're now trying to think, do we get the same factor when we factorize these two as when we factorize these two? Well, let's see what happens when we factorize these two. Well, we're getting minus x and x minus 1 there. And I can see here, well, actually, that one factorizes as x and x squared minus 1. But now I can see that I have got, in fact, a factor of x minus 1. So I can see that this is the difference of two squares. So I've got x minus 1 there, and I've got 6 x minus 1. Obviously, all of these things are equal. And obviously, this is equal to 0 as well. I'm kind of missing that. Sorry about that. It's equals to 0 on. Let's just make it complete for the examiner. And now we can see that we can factorize out x minus 1 here. So we've now got x minus 1, x plus 1, and sorry, let's just take away that, and minus 6. So we've got this amount of x minus 1, and we've got minus 6 lots of x minus 1. We factorized out this term here in both of those cases. Now we can simplify this. Okay, and now we've got x squared plus x minus 6. And now finally, this factorizes as well. So we've got plus 3 and, sorry, it's just fitting this one in. We've got x plus 3 there, and we've got x minus 2 there as well. So that's our final line of working out. Sorry to squeeze it in at the bottom. Okay, now from my point of view, the line where we're trying to get from here to here is really difficult. It's difficult to think that one through. And again, I mean, you can do the same. It's sort of like the same thinking, really, as saying, well, look, we've got two numbers. If we time together the 1 and the 6 here, we've got two numbers times together are equal to the 6, and that add together are equal to minus 7. Okay, and that's minus 1 and minus 6. So it is the same thinking as what a lot of you will be doing with those quadratics, which have a 2x squared or a 3x squared, or a coefficient which is of x squared, which is not 1. It's that same thinking in order to split up the middle factor. But that's not explained by what's happening in the book. The book just takes you from this line to this line. Really, you're trying to solve this puzzle over to the side in order to get there. And to be honest, most people just do this puzzle over here in their head in order to factorize with quadratics. Okay, so I wouldn't promote this. So, okay, well, what would I promote for this question? Okay, and I would think that if this one factorizes, and we're expecting this one to in this case, okay, because it's telling us to use algebra, we've got to think about what our possible factors are. Okay, now possibly in the exam it might say through factorization, but if we're going to factorize this thing here, well, we know that we're going to get brackets where we'll have x, x, and x. And we're hoping that we're getting rational numbers in these three places here, or integers, in fact. If we have like a 2 in front of that, then we would put a 2 there and we might get rational numbers instead. But okay, so we're going to have this format is equal to our cubic. And we've got to think that our three, let's call them A, B, and C, those are our roots, A, B, and C, and our factors are x minus A, x minus B, and x minus C. Now, when we multiply these three things out, we're expecting to get 6. So when we do minus A times minus B times C, so two of those minuses are going to cancel, we're going to get plus 6. So that means that A, B, and C, as long as we have a factorizable cubic here, that means A, B, and C are going to equal to plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, but so for example, A, B, and C could be, I don't know, you could have 1 times 2 times minus 6 would give you out plus 6 when we're adding that minus on in front. But either way, we'd have combinations of, messing this up a little bit here, minus 3, of course, right? But either way, we'd have combinations of these factors here, plus or minus the factors of 6. Okay, so let's take that back a little bit. So from my point of view, I would now say, okay, well, let's just try out some of these factors. So it's really easy to try out plus or minus 1 to start off with. If we put in plus 1, we can see straight away we're getting out 1, getting a minus 7, and we're getting a plus 6. So we're seeing that f of 1 is equal to 0. So we know, therefore, that x minus 1 is a factor. Okay, well, when we know one of these factors, then we can do our division of polynomials. Now, you could potentially use here Horner's algorithm, but let's just try a division of polynomials by long division here. And we've got x cubed. And remember, we've got plus 0 lots of x squared. And then we've got minus 7x. Just going to give myself a bit more space here. We've got x cubed plus 0 lots of x squared minus 7x, and then plus 6. What we're dividing this by is x minus 1. Okay, x into x cubed is going to go x squared times. Let's multiply this by this. We've got x cubed there, and x squared times by minus 1 is minus x squared. When we subtract those two things, we're getting x squared. Bring down the minus 7x. X is into x squared goes once. X times by x squared times by x at the front is x squared. X times by minus 1 gives us minus x. The subtraction of those two things is not 8, it's minus 6x. Let's bring down the plus 6. Now x into minus 6x gives us minus 6. 6 times by this thing here should hopefully give us 6x plus 6, leaving no remainder. So that's the approach that I take here. And then we can see that this is our quotient. And so now we've got our function is equal to x minus 1, and this quotient x squared plus x minus 6. And then again, we can split up this x squared plus x minus 6 by just doing a factorization. Now that to me is a lot quicker than thinking about splitting up the middle term here and hoping that that works and trying to go through my combinations for that. Okay, so I don't think it's necessarily obvious to split up the middle term. I think it's much easier to go through trying plus or minus 1, plus or minus 2. By the time that you've done those two, you're expecting to have found one of your factors. We happen to find it by putting in x is 1 to start off with, but it might be that if that wasn't a factor, we would have had to have tried minus 1 and then plus 2 and then so on. Okay, but sooner or later you're going to find a factor, and once you find a factor, you can do your division. Now, if you want to, you could find all of your factors in this case by just going through your combinations here. So go through plus or minus 1, go through plus or minus 2. And in fact, by that time, you'll see, so we get, what do we got? Plus 3 again, and doing earlier, the minus 2 there. So by the time we've gone through plus 1, okay, so what we've done that, and then we go through plus 2 and realize we get a 0, and we get a factor, then it's very easy to see what the remaining one is, because you'll notice that these three things need to times together to give you your minus or plus 6. So of course, the last one is easy to find, so long as it does factorize. Okay. So you might want to check your answer if you were doing that, and then actually just multiply it out to check that you've got the right thing. Okay, well, that's a fair bit of chat. You can see what the book is doing there. Or we actually haven't solved the equation here, we've only just factorized it. In order to solve it, we just need to give the opposite of what's in each of those brackets there. Okay, well, there you go. There's some techniques. And there's a final technique here. It says you can check these on the calculator as well, or you could use a calculator to find your zeros simply by plotting the graph and finding where it crosses the x-axis, which hopefully is pretty obvious. Okay, so 3n, this little bit here. And, you know, I'm going to stop there. Unusually, I'm not going to add on anything more. Probably done that in about 15 minutes. And there we go. I'll give you a little time off there. Okay, guys, well, thanks for listening, and hope to see you for the next one.